more than anything, this video is probably going to end up just being an English lesson. I need to talk to you about what the difference is between explicitly defined functions and implicitly defined relations. And a part of the motivation of this video is I sort of want to redeem the word explicit. Like when I say explicit, generally speaking, the first thing that comes to people's minds is explicit lyrics. There's a sense of like, oh, explicit means bad. We just don't talk about those things, and that's not true at all. The word explicit actually means something really, really useful. So if something is explicit, what it means is that it's just expressed very clearly and it leaves nothing to be inferred. I feel like when I leave lesson plans for a substitute, if I ever leave instructions on the board, I try to make those instructions very explicit and very clear. Right? And so the reason that a musical album will sometimes say it as explicit lyrics is they're just indicating that some of those lyrics are just very clear. Like you don't need to guess what the artist is talking about when you're listening to the song. And in those contexts, explicit does take on another meaning, but I want you to know that the word explicit doesn't necessarily mean, vulgar lyrics. We contrast it with the word explicit or implicit. So on the other hand, if something is implicit, it often means, and there are multiple definitions, but it often means that much of the meaning is implied rather than expressed, well explicitly. So at the end of a day, when there's 3 seconds left in the period, and I say, hey everybody, remember to go online and do what you need to do, I'm not telling you to go to the specific website and click the first link and watch the 3 videos. I'm saying, look, you know what you need to do. Just, hey everybody, heads up, remember, do the work that you need to do, right? Those are implicit instructions as opposed to explicit instructions, right? So what does this have to do with math, and why am I talking about it, right? Well, the reality is that the majority of functions that you have dealt with have been explicit functions. And what I mean by that is when we say, y, or, not even y, when we say that f of x equals x squared minus 3x plus 4, and actually now that I think about it, I do kind of want to use y there. This function is incredibly explicit. If you want to know what output you will get, all you need to do is evaluate this for a certain value of x, and as soon as you put in values for x, you immediately know what y is. There's absolutely no ambiguity here as to what the output is going to be. Like, it is perfectly clear what your output is going to be when you input a certain value, right? Contrast that with implicitly defined, and they can be functions, they're often relations. You guys have seen very, very few of them in your limited mathematical experience so far. One of the most easy to think about is a circle. X squared plus y squared equals 25. Right? And the idea here is, when I input something for x, how clear is it what y is going to be? It's a lot less clear. If I let x take on some value, I have to subtract that x over, I have to take the square root of both sides. For that matter, when I plug in an x value, when I evaluate for an x value, there actually end up being multiple y values. And so this is what I would call an implicitly defined relation. And on the other side, over here, we have an explicitly defined function. In the next video, I want to talk about how we deal with derivatives when the functions or the relations are defined implicitly, right? Everything we've done so far with derivatives has been with explicitly defined functions. We find the derivative by just taking the derivative. And in some sense, like if we were taking the derivative of this, right, when we do it, the derivative would be 2x minus 3, and what would we write on the left side? Well, we would write dy dx. Why? Just kind of because that's what it is. In the next video, I'm going to be talking a little bit more about what goes into this and how we can apply those principles to deal with finding the derivative in this case. So I'll see you in the next video.